A solar thermostatic controller is different from a standard household thermostatic controller in that two sensors are used rather than one to activate a pump and collect solar heat. Simply put, a pump is activated when a collector probe is hotter than a storage probe. But how much hotter should it be? What should the temperature difference be between the collector and storage to turn the pump on or to turn the pump off? This particular controller also has a barcode indicator that allows us to monitor both collector and storage temperatures. If we set the differential too high, we'll collect less heat, but if we set the differential too low, the power consumed by the pump may be greater than the heat collected by the pump. Of course, the ideal setting will be different for each application, but this setting should take into account both the heat harvest and power used to harvest the heat. A counterclockwise setting will maximize heat collection, and a clockwise setting will maximize energy conservation. What you're looking at is a differential thermostat with a barcode indicator. This is the barcode indicator, and it indicates a temperature change from 90 degrees to 150 degrees. Okay, you'll see this in a minute. Now when this switch is on the up position, we'll be looking at the collector temperature, and when the switch is on the down position, we'll be looking at the storage temperature. Right now, the differential is set to maximize the heat harvest. It's a very low differential, so it won't take too much heat to turn the pump on if the collector temperature is hotter than the storage tank temperature. But for right now, I'm just going to raise the temperature of the storage probe, and we can see how that influences the barcode. And you can see it going up pretty rapidly. Okay, so that's about 140, 130 degrees or so for the barcode. So the storage tank temperature is high. The collector temperature is still below 90 degrees, so the pump doesn't go on, and that's exactly what we'd expect. We don't want it to go on when the storage tank temperature is high. We want the pump to transfer heat from the collector when the collector is high. Okay, now let's raise the temperature of the collector. We have the switch set on the top position, so you can see the collector temperature. So the collector temperature is about 120 degrees. The storage tank temperature is much lower than that. Actually, it came on even sooner than that. So in order to turn the pump on, or turn the pump off, we can raise the temperature on the storage. The storage, there we go. So when the storage tank temperature is hotter than the collector temperature, the pump comes off. Now this is a very sensitive differential setting. Usually you wouldn't set it this low. It's actually about 5 degrees to turn it on, and probably about 2 degrees to turn the pump off. Now let's set this differential a little higher and see what happens. Okay, now it's going to take a lot more heat to turn this pump on. You have to get it all the way up there, about 150 degrees. So the differential might be 50 to 60 degrees or so to turn it on. So the collector has to get really hot. The setting is like this to increase the differential. Okay, that's the basic idea. Now let's see what temperature the pump comes off at. Okay, we raise the storage tank temperature. Okay, so it's a little hard to see these subtle changes, but in actual operation, the collector temperature can get quite high. It can go over 200 degrees, and the storage tank temperature sometimes can get 150 degrees. Anyway, this is just one model. This is the model that has a minimum temperature of 90 degrees and the maximum temperature of 150 degrees to indicate it. The differential setting is still the same, and there are other differential controllers that have a different range of temperature. Anyway, this is the basic idea. Thank you very much for your time. That's the idea of the differential thermostat with the barcode indicator. Right now it's set for the maximum heat harvest, but suppose we want to conserve power. Well, if we turn this potentiometer in the other direction, the pump will come on when we raise the collector temperature. Let's raise the collector temperature, but it has to be raised much higher. You see, that's about 140 degrees before it came on, and now we raise the difference in temperature to shut it off won't be quite so much either. So this is a way of conserving power. So remember, the differential pot adjustment, if we turn it this way, will maximize the heat harvest. The pump comes on already. If we turn it this way, we maximize energy conservation. In other words, the pump will only come on when the temperature of the collector is very high. So we'll collect a lot of heat for a short period of time, and we'll conserve energy at the same time. Anyway, that's the basic idea of the differential thermostat with the barcode indicator. Well, thank you very much for your time.